The concept of time has fascinated humanity for millennia. From ancient philosophers to modern physicists, the question, what is time, has remained one of the most profound and elusive in human inquiry. Time governs our lives, yet its essence escapes simple definition. From the metaphysical reflections of St. Augustine in the 4th century to Albert Einstein's revolutionary theories in the 20th century, our understanding of time has evolved in tandem with developments in philosophy, science, and technology. This essay traces the intellectual journey from Augustine's contemplations to Einstein's relativity, showing how our conception of time has shifted from subjective experience to objective framework. Augustine's paradox of time. St. Augustine of Hippo, in his Confessions, Book Zaren, famously posed the question, what then is time? If no one asks me, I know. If I want to explain it to someone, I do not know. Augustine's approach to time is deeply introspective and theological. He grapples with time not as an external entity, but as a phenomenon rooted in human consciousness. For Augustine, time does not exist independently in the way material objects do. Instead, it is an aspect of the mind. He divides time into 3 parts, the past, present, and future, but immediately complicates this by noting that the past no longer exists, the future does not yet exist, and the present has no duration. Thus, time seems paradoxical. To resolve this, Augustine suggests that the 3 divisions of time correspond to functions of the human mind: memory, past; attention, present; and expectation, future. Time, then, is a measure of the soul's experience. It does not exist objectively, but only as a subjective feature of consciousness. In this sense, Augustine can be seen as a precursor to later phenomenological thinkers, emphasizing the role of the observer in constructing temporal reality. Newtonian time, absolute mathematical ground. Over a millennium later, the rise of modern science brought a drastic transformation in the understanding of time. Isaac Newton, in the 17th century, redefined time within the framework of classical mechanics. In his Principia Mathematica, 1687, Newton describes time as absolute, true, and mathematical, flowing equably without relation to anything external. Newtonian time is independent of the events that occur within it. It acts as a constant backdrop to motion and change. This notion of absolute time enabled scientists to measure durations and predict physical phenomena with remarkable precision. Time became a universal parameter, homogeneous and unchanging, the same for all observers, regardless of location or motion. This conception of time reigned supreme for over 2 centuries. It served as the foundation of physics and allowed for a mechanistic view of the universe, deterministic, predictable, and objective. Kant and the a priori nature of time. Immanuel Kant, writing in the 18th century, offered a nuanced philosophical critique of Newtonian time. In his Critique of Pure Reason, 1781, Kant argued that time is not an empirical concept derived from experience, but rather a necessary condition for the possibility of experience itself. Kant posits that time and space are forms of intuition, a priori structures imposed by the human mind to organize sensory input. In other words, we do not perceive time because it exists in the external world. We perceive the world in time because our minds are structured to do so. Kant's transcendental idealism thus occupies a middle ground. Time is not merely subjective as in Augustine, nor purely objective as in Newton. It is a necessary precondition for our experience of the world, shaped by human cognition. Einstein's relativity, the end of absolute time. The most dramatic shift in the understanding of time came with Albert Einstein's theories of relativity in the early 20th century. In his Special Theory of Relativity, 1905, Einstein challenged the Newtonian notion of absolute time. He demonstrated that time is not constant, but relative, depending on the observer's state of motion. One of the key insights of special relativity is time dilation, the idea that time passes more slowly for an object in motion relative to a stationary observer. This has been experimentally confirmed using atomic clocks on high-speed jets and satellites. Time is no longer universal, it is intertwined with space, forming a 4-dimensional continuum known as spacetime. In 1915, Einstein's general theory of relativity extended these ideas to include gravity. Here, Einstein proposed that massive objects cause the fabric of space-time to curve, and this curvature affects the passage of time. Clocks run slower in stronger gravitational fields, a phenomenon confirmed by observing time differences between clocks on Earth and those in orbit. Einstein's theories revolutionized not only physics but also philosophy. They redefined time from an independent absolute to a dynamic quantity influenced by matter, energy, and motion. Time became part of the physical universe, subject to the same laws and limitations as other natural phenomena. The block universe and the illusion of flow. One of the most intriguing implications of relativity is the concept of the block universe, or eternalism. In this view, all points in time, past, present, and future, are equally real. The universe is like a four-dimensional block, and the flow of time is an illusion generated by consciousness moving along the timeline. This challenges our everyday experience, which is rooted in a present moment, constantly shifting toward the future. Yet in the block universe, there is no objective now. Events exist in space-time much like locations on a map. We perceive a temporal sequence, but the universe itself does not change. Philosophers and physicists alike continue to debate the implications of this view. Some, like Hermann Minkowski, embrace the fusion of space and time. Others, like Lee Smolin, have argued for a more dynamic, evolving notion of time. The tension between subjective experience and physical description remains unresolved. Time in quantum mechanics. While Einstein's relativity transformed our macroscopic understanding of time, quantum mechanics introduced new puzzles at the microscopic level. In quantum theory, time remains a background parameter, but its role is more ambiguous. The famous measurement problem in quantum mechanics, where the act of observation collapses a system's wave function, raises questions about the role of time in determining physical reality. Additionally, efforts to reconcile quantum mechanics with general relativity have produced speculative models where time may emerge from more fundamental processes or may even be quantized. Some approaches in quantum gravity, such as loop quantum gravity and string theory, suggest that space-time is not continuous, but made up of discrete units. In these models, time may not be fundamental at all, but a macroscopic phenomenon emerging from a timeless substratum. Time and human consciousness. Despite scientific advances, time continues to be deeply tied to human consciousness. Psychological studies show that our perception of time is malleable. It speeds up or slows down depending on attention, emotion, and memory. Trauma, boredom, and euphoria can distort our temporal experience. Thus, time remains a bridge between the physical world and our inner lives. Modern philosophers like Henry Bergson have argued for a distinction between mathematical time and lived time, la durée, emphasizing the fluid, qualitative experience of time over the quantitative, measurable one. This echoes Augustine's early insights and underscores the enduring complexity of the question. Conclusion. From Augustine's introspective paradox to Einstein's relativistic universe, the concept of time has undergone profound transformation. Each era, religious, philosophical, scientific, has offered different answers shaped by its intellectual tools and cultural context. Augustine saw time as a property of the mind. Newton made it absolute and external. Kant placed it within the structures of human cognition, and Einstein wove it into the very fabric of the cosmos. Yet despite these advances, time remains an enigma. Is it a fundamental feature of reality or an illusion born of perception? Is the future predetermined, or do we play a role in shaping it? Can time begin or end? Ultimately, the question, what is time, may never yield a final answer. But in seeking it, we uncover not only the structure of the universe, but the essence of our existence within it.